At 47 kilometers per second, the interstellar object designated 3I/Atlas cuts through the solar system on a trajectory known celestial mechanics can explain. Its coma brightens by 22% in just 6 hours, far faster than typical volatile release should allow at its current heliocentric distance. Instruments record a sudden, measurable shift of 0.08 degrees in its outbound path, a deviation too large for random outgassing alone. Something is steering its journey into the unknown. At the edge of astronomical detection limits, a faint teal glimmer drifts across a wide-field survey image, no brighter than a grain of dust against the darkness. It appears at first as nothing more than a minor smudge in the digital noise. But its motion tells another story. Frame by frame, it shifts with a velocity far too great for any object bound to the sun. Within hours, orbital solvers confirm the impossible. The newcomer's eccentricity exceeds 1.15, a mathematical fingerprint that marks it as an interstellar migrant. It has not come from within the solar system. It has come through it. As observatories in Chile, Hawaii, and the Canary Islands retarget their lenses toward the anomaly, its spectral signature begins to unfold. Instead of the carbon-water ratios typical of solar-borne comets, the object, soon designated 3I/Atlas, reveals a chemical fingerprint strikingly unfamiliar. Spectroscopy shows volatile compounds in proportions neither seen in Oumuamua nor Borisov, its two known interstellar predecessors. Traces of nitrogen-rich organics mingle with crystalline ices in a configuration that suggests a birthplace shaped by very different stellar chemistry. Perhaps a region where massive stars once lived and died, seeding nearby protoplanetary disks with exotic materials. Then, another anomaly emerges. Its luminosity fluctuates with a precise 10.4-hour rhythm. Not a simple spin, not a chaotic tumble, but a patterned oscillation implying rotational dynamics that defy standard cometary behavior. The nucleus may be irregular, fractured, or even hollowed by ancient processes that left it unable to rotate like any known natural fragment. As 3I/Atlas slips deeper into the heliocentric corridor, its behavior only grows stranger. Crystalline water signatures sharpen and intensify, yet at its current distance, the sun's radiation is far too weak to trigger such dramatic sublimation. Standard thermal models fail. The energy required to produce these transitions cannot be explained by passive heating. Somewhere beneath its surface, heat is moving, accumulating, or being released in ways no inert object should allow. Researchers begin to compare the incoming data with models of tidally disrupted exoplanets, worlds once torn apart by their stars, leaving behind mineral-rich shards that wander between systems. The resemblance is striking. Silicate patterns match what would be expected from material once compressed deep within a planetary mantle. Yet the volatile layers behave as though they were deposited long after such an event, as if 3I/Atlas assembled itself from fragments of different cosmic histories. Each observation deepens the enigma. Why does the object brighten in defiance of prediction? Why do its reflective surfaces reorganize across only a few days? And why does its internal composition appear so varied, as though carrying the geological memory of multiple star systems? Across the global scientific community, unease grows alongside curiosity. The newcomer does not behave like a comet, an asteroid, or a rogue planetary shard. It behaves like something undergoing change, reacting to its environment, adjusting as it approaches the sun. And as 3I/Atlas continues its silent glide inward, one unsettling question rises above all others. Something inside this interstellar wanderer is awakening faster than physics allows, and its next evolution will determine whether it is simply unusual or unprecedented. At a heliocentric distance of more than 300 million kilometers, 3I/Atlas glides across the void with the steadiness of a silent metronome. Its path, at first, adheres perfectly to mathematical predictions, a clean hyperbolic arc typical of interstellar visitors. But then, in a line of code buried within a routine calibration test, a subtle discrepancy appears. A single measurement, off by a fraction, so small it seems insignificant, 0.08 degrees. Barely more than a whisper in space. And yet, when mapped against its velocity, nearly 47 kilometers per second, this whisper becomes a shout. The object has changed direction. Observatories repeat the measurements. Different instruments, different atmospheric conditions, different protocols. The result refuses to shift. The anomaly is real. Something has imparted an impulse equivalent to billions of newtons, yet without the characteristic flare, spike, or thermal signature expected from sudden outgassing. The turn is not abrupt. It is smooth, continuous, deliberate in its mathematical elegance. No natural mechanism currently known can replicate such behavior with this level of precision. Analysts begin dissecting the possibilities. Internal vents releasing pressure in synchronized patterns. Cascading fractures distributing momentum through rotational torque. Chemical asymmetries triggering evaporation gradients. But each theory collapses under the unforgiving framework of physical law. The energy budgets do not align. The mass distributions do not help. The rotational dynamics refuse to cooperate. What remains is not a solution, but an expanding void of uncertainty. Then the deep imaging arrays deliver their next revelation. Along the object's fractured surface, narrow linear fissures glow faintly as transient jets burst outward, but not in the chaotic plumes typical of comets. These jets are thin, collimated, restrained, as if shaped by internal geometry. Within them, instruments detect carbon structures arranged in repeating motifs, complex but ordered, each pattern echoing a molecular rhythm seldom produced in such abundance by natural processes alone. It is not evidence of life, not evidence of machinery, but it is evidence of organization, a property often associated with purpose. When the object's orbit is recalculated with a new turn factored in, a striking trajectory emerges. 3I/Atlas is now aligned with a narrow gravitational corridor threading between Mars and the asteroid belt. This is not an energy-efficient slingshot. It is not a collision pathway. Instead, it is a route that brings the object into maximum observational clarity for nearly every major instrument humanity has deployed around the inner planets. Solar observatories, deep space arrays, planetary probes, all positioned by historical coincidence along the path it has now chosen. The timing is uncanny. The geometry is exact. Yet the implications feel too vast to accept without caution. Scientists know the dangers of projecting intention onto nature. The cosmos is filled with phenomena that mimic purpose yet arise from randomness. Still, the pattern persists. A turn without precedent, jets without chaos, materials without simple origin, and a trajectory that places the object in the brightest possible spotlight. Around the world, researchers feel a growing weight behind the data, a pressure born not of fear, but of recognition. Something about 3I/Atlas is asserting a logic that resists conventional explanation. And if its path truly follows a guiding principle, the next question becomes inescapable. What force, natural or otherwise, determines the direction of a visitor that does not belong to this star? At a distance where sunlight reaches with only a fraction of its former strength, 3I/Atlas glimmers like a muted ember suspended in darkness. Yet within that dim glow, something unusual pulses, subtle shifts in the polarization of reflected light, cycling with a precision that no ordinary comet should possess. High-resolution polarimetry reveals rhythmic modulations repeating with a consistency more reminiscent of structured crystalline matrices than of chaotic dust clouds. The pattern persists across wavelengths, as if the object carries an internal symmetry broadcasting itself through faint optical fluctuations. Not noise, something patterned. Adaptive optics sharpen the view further. exposing a striking thermal anomaly. Instead of a random mosaic of hot and cold patches across its nucleus, a coherent heat plume sweeps laterally beneath its surface. It moves like a wave, cresting and fading with the cadence of controlled energy transfer. Cometary bodies typically betray disordered heat signatures, erratic flows governed by fractured pores and sublimating ice. But here, the heat behaves with elegance, as though guided by hidden conduits or hollowed spaces that channel thermal radiation along predetermined routes. Geometry where none should exist. Spectroscopy deepens the mystery. Within the ejected particulates are compounds that defy simple evolutionary history. Ammonia hydrates resting beside fused silicate glass, metallic sulfides threaded through nitrogen-rich organics. These materials originate from environments with wildly different temperature and radiation conditions. Some form in the hearts of icy protoplanetary disks. Others require the furnace of extreme tidal forces or catastrophic stellar events. Their coexistence inside a single object suggests a journey far more complex than a linear drift through interstellar space. It hints at assembly rather than accretion, combination rather than coincidence. Even more surprising are the isotopic ratios. Certain fragments show signatures indicative of supernovae-enriched material, while others reflect the quiet chemical gradients of molecular clouds untouched by violent astrophysical events. Together, they read like a chronology written in elemental scars, each compound whispering of a different region, a different epoch, a different chapter in a voyage across the galaxy. The object appears to be a vessel of mixed histories, shaped by forces far beyond the imagination of early planetary formation models. Researchers confront a problem of interpretation. Could 3I/Atlas be a shard torn from an exoplanetary crust, later coated in volatiles, while passing through dense nebular filaments? Could it be a remnant of a planetesimal shattered by stellar tides, later stitched together by processes as yet unknown? Or could it represent something even more elusive, a structure whose assembly is neither accidental nor fully natural in origin? As instruments dig deeper into its spectral and thermal language, the patterns in the dust begin to resemble a form of organization. Not linguistic, not biological, but structural. The particles align in distributions that mirror mathematical sequences found in certain crystallographic growth processes. These sequences, when modeled, echo the kind of recursive complexity that emerges when matter evolves under constraints not yet understood. Matter shaped by purpose, or by phenomena indistinguishable from purpose. The closer the observations become, the more the object resembles a messenger, one carrying layered records of encounters across star systems, each etched into its shifting surface. And as the dust trails reveal increasingly intricate patterns, a question begins to take shape, quiet yet overwhelming. The structures within 3I/Atlas may encode a story older and far more intentional than anything Earth has ever deciphered. A thin pulse of radio static sweeps across the solar wind, an almost imperceptible tremor riding the electromagnetic hush between planets. It lasts less than a second. Then another follows, and another. By the fourth day, a pattern has formed, threading itself through multiple frequency bands like the faint heartbeat of a visitor drifting through the inner system. To most receivers, it is noise. To the network of observatories now synchronized across Earth and beyond, it is the first sign that 3I/Atlas is not simply passing through, but interacting. Across space agencies, a rare unity takes shape. NASA draws deep space antennas into coordinated phase lock, while ESA's solar orbiter shifts its orbit in a maneuver usually reserved for emergency solar event tracking. JAXA reassigns its high-resolution spectrometers, and CNSA recalibrates lunar array receivers to filter the rising harmonic clusters embedded in the static. Even the usually slow-moving bureaucracies bend under the weight of a singular scientific imperative: capture everything before time runs out. The microbursts intensify as 3I/Atlas crosses the orbit of Mars. Their structure refuses to align with any known astrophysical mechanism. Each emission splits into precise harmonic intervals, spaced too consistently to attribute to turbulent ejecta or rotating debris. It creates an unanswered question that deepens with every transmission. What natural object behaves as though its noise carries intention? Side-on imagery from Mars orbiters reveals the visitor in unprecedented clarity. Against the darkness of space, the object glimmers with irregular symmetry, its surface neither wholly smooth nor wholly fractured. But the real surprise lies in its behavior as solar flux increases. By all standard thermal models, its outer layers should begin to vaporize, shedding streams of dust and volatiles into a glowing coma. Instead, the opposite occurs. The surface contracts, edges sharpen, reflective facets emerge like plates aligning under invisible command. Thermal data shows that, rather than overheating, 3I/Atlas stabilizes its temperature profile with almost mathematical precision. It absorbs, redirects, and radiates energy through a system that resembles thermal regulation more than passive physics. Inert matter should not behave this way. Cometary nuclei do not rearrange themselves to maintain equilibrium. Yet the data remains unyielding. 3I/Atlas adapts to the sun's increasing intensity with the calm resilience of something engineered or shaped by processes unknown. Speculation spreads across mission rooms and academic circles alike. Some propose that the object is composed of metamaterials formed in the intense fields of magnetar remnants, capable of reconfiguring at microscopic scales. Others consider it a fractured megastructure, long dead but still following the remnants of an ancient instruction set embedded in its crystalline lattice. A more conservative faction argues for unknown thermal mineral couplings, emergent properties of exotic interstellar chemistry. But none of these theories fully explain the harmonic pulse emissions or their growing regularity. As days shorten into hours, the solar system shifts from passive witness to uneasy participant. Arrays across multiple worlds now echo with the faint signatures of the visitor's microbursts, as though the object is mapping the heliosphere, or applying to something only it can detect.